Hi guys, in today's video, I'm going to be starting on the second chapter of the AP Calculus BC syllabus. This is derivatives. So this is the second unit. A derivative is an average rate of change. So it's the average rate of change. The average rate of change or change in y over change in x. So this is how you can write it. So the definition of a derivative. So there are two ways where you can write a derivative. So f dash of c or f prime of c, you can say whatever. That is equal to limit x tends to c f of x minus f of c divided by x minus c. So this is the first definition of a derivative. Another formula for definition of derivative is f of x equals f of x plus h minus f of x divided by h. So these are the two forms of definition of derivative. Okay, so now I'm going to be teaching you one rule. So a function f is said to be differentiable. So it's differentiable at x equals c if the derivative of f exists at x equals c. So f is said to be differentiable at x equals c if the derivative of x, if the derivative of x if the derivative of f, sorry, exists at x equals c. Exists at x equals c. So this is a rule which you have to know. So a function f is said to be differentiable at x equals c if the derivative of f exists at x equals c. So now let's look at some places where f is not differentiable at x equals c. So the first case is when f has a sharp turn. So when it has a sharp turn, it's not differentiable. Sharp turn. Let me give you an example. F of x equals modulus x minus 2. So f is not differentiable at x equals 2. So at x equals 2, it's not differentiable. It's not differentiable because there is a sharp turn. So this is what a sharp turn looks like. But however, it's differentiable for all other values of x. Now let's look at the second case where it's not differentiable. When there is a discontinuity at a value. Where there is a discontinuity. So now let me draw a graph. See, a graph looks like this. And this is the value 2. And it just keeps going up like this but it will never touch this line. So f is not differentiable at x equals 2 again. It is not differentiable Because there's a discontinuity at x equals 2. That means the graph never touches this. This is a vertical asymptote. The graph never touches this line of x equals 2. So then hence you can't differentiate it then, right? Yeah. So now let's look at the third case. Third case is when there is a vertical tangent. When there is a vertical tangent. So let's say a graph looks like. So this is at 1, x equals 1. So at x equals 1, it's not differentiable because there is a vertical tangent. So you can see that this line is vertical, right? At x equals 1, the graph is vertical. But f is, however, it's differentiable for all other values of x. Finally, the fourth case where it's not differentiable, function f, is when there is a cusp. Let me give you an example. So it looks something like this, a cusp. So x equals 1. So at x equals 1 again, it is not differentiable, this graph, because there is a cusp. But for all other values of x, it is differentiable. Okay, that's it for today's video, guys. In today's video, I introduced derivatives and I explained when the four cases for when a function f is not differentiable. Thank you.